Good afternoon. Evening. Good afternoon. Today I am going to tell something about complex number. Okay. So complex number. Okay. If I talk about complex number, then a complex number of form a plus iota b. Any number of this form is known as complex number, where a and b both are real numbers. These two numbers are real numbers. And I means iota, and iota means value of iota is root over minus 1. That means iota square equal to minus 1. So any number of this form is known as complex number. Suppose 3 plus 2 iota. This is a complex number. Okay. This is general form of complex number. Another form of complex number is polar form. Polar form. So what is polar form? This is main target for today. So if a number is like this, a plus iota b, this means this complex number represents a point a comma b in a complex plane. Here suppose this is our y-axis and this is x-axis. This is also known as the real axis. This is real axis and this is known as imaginary axis. Imaginary axis. And this plane, coordinate plane, is known as complex plane or Gaussian plane. Okay. So a plus iota being a comma b. Suppose a comma b is this point p. P is nothing but a comma b, and this point denotes the complex number a plus iota b. Now, if you join this point with the origin, then the length of this radius vector joining the origin to this point, the length of this vector is known as the modulus of complex number a plus iota b. If you denote a plus iota b as z, where z is a complex number a plus iota b, then modulus of z is denoted by z mod, and this is nothing but the length of this radius vector. If suppose you are projecting a perpendicular from this point to the x-axis or real axis, then this length will be a and this length will be b, and this is 90 degree. So by Pythagoras theorem, you can say that mod of z, that is modulus of z, is equal to root over a square plus b square. And here, this angle, the radius vector, that is the angle between the radius vector and positive x-axis. Suppose this is theta, then theta is nothing but the argument of complex number. Okay, argument of z, and you can write it as arg argument of z is equal to theta. Now apply here in this triangle you can apply sin theta or cos theta. So in the same triangle, here a triangle is formed. So in this triangle, sin theta equal to perpendicular upon hypotenuse. So perpendicular is b, upon hypotenuse is mod of z. Suppose this mod of z is equal to r. Let us say this is r. So b by r. This implies B equal to R sin theta. Similarly, if you apply here cos theta, then you will get A equals R cos theta. But you know that Z is equal to A plus iota B. This is equal to what you do? You just write R cos theta in place of A and R sin theta in place of B. So what you will get? R cos theta plus iota times R sin theta. This is equal to, if you take R common, you will get R under bracket cos theta plus iota sin theta. So the same complex number A plus iota B can be written as R into cos theta plus iota sin theta. So this is known as polar form. This form is known as polar form. Where what is theta and what is R you already know from this expression. Here theta, how can you find the value of theta? Just you apply here tan theta. So tan theta equals B upon A, because tan theta is perpendicular upon base. So in this triangle, perpendicular is B and base is A. Remember, this B by A will not always give you the proper value of theta. You have to consider the proper quadrant in which the point P is lying. Suppose if the point P is lying in the third quadrant, then this value B by A will not give you proper value of theta. So we have to consider the quadrant in which P is lying. Okay. So next, what you got? Z is equal to A plus iota B. This is general form, which can be written as R times cos theta plus iota sin theta, and this is what? This is polar form. Okay. Now we have one expression for cos theta, sin theta, and exponential function. We have cos theta. You can write cos theta is equal to 1 minus theta square by 2 factorial plus theta 4 by 4 factorial minus theta 6 by 6 factorial plus dot 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 up to infinity. Similarly, we have a series for sin theta. So sin theta equals theta minus theta 3 by 3 factorial plus theta 5 by 5 factorial minus dot 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 like this up to infinity. And we have e to the power x equals 1 plus x upon 1 factorial plus x square by 2 factorial plus xp by 3 factorial like this up to infinity. These all expressions can be proved using the Euler series or Maclaurin series, which you will study in the higher classes. So here e to the power x is these things. What you do, you just replace x by, here in this formula, you just replace x by I theta. So what you got? E to the power I theta equals 1 plus I theta upon 1 factorial plus I theta square upon 2 factorial plus I theta q upon 3 factorial plus I theta 4 factorial like this up to infinity. And what is the value of I? You already know the value of iota is root of -1. So iota square is equal to -1. Similarly, you will get iota q is equal to minus iota 4 is equal to 1, like this. So this is equal to 1 plus iota theta. Iota square will be equal to -1. So minus theta square by 2 factorial. Iota q will be equal to minus iota. So minus iota theta q by 3 factorial. Iota 4 will be equal to 1. So theta 4 by 4 factorial plus up to infinity. Now what you see here? This is iota theta. This terms contain iota. this term contain iota, and here also many terms will contain iota. So you collect all the terms containing iota at one place and the term independent of iota at other places. So what you get? E to the power I theta equals, you can see here, 1 minus theta square by 2. Next independent of theta will be theta 6. So 1 minus theta square by 2 factorial plus theta 4 by 4 factorial, like this. And plus the term containing iota, I theta, this q, that means I, you can take I common. So theta minus theta q by 3 factorial. Next will be theta 5 by 5 factorial minus, like this, up to infinity. Here also up to infinity. So this is what? This is expression for cos theta. You all know these things. So e to the power I theta equals, you can say, cos theta plus iota times, this is what? The expression for sin theta plus sin theta. This is known as Euler identities. Euler identities. Okay. And here we had an expression for complex number this. That means Z equals A plus iota B. You can write it in polar form. Cos theta plus iota sin theta. And you can write for this cos theta plus iota sin theta from here e to the power I theta. So r e to the power I theta. So these three expressions are same. This and this both are same complex number. This is general form, this is polar form, and this is Euler form of complex number. Here r is what? You know, modulus, distance between the origin and the point, and theta is what? The argument of complex number. This Euler form many times simplifies the complex problem. For example, suppose you are taking an example. Suppose we have a complex number z equals I to the power I to the power I, iota to the power I to the power iota. And we have to find the modulus and argument of this complex number. So here, Euler form will be better. What is Euler form? Suppose we have a complex number z whose modulus is r, and argument of this complex number z is theta. Then the complex number z can be written as r into e to the power I theta. So I to the power iota. See, this is iota. You can say this iota, you can write this iota as iota equal to 0 plus 1 times iota. So if you compare this with a plus iota b, what we will get? A equals 0, b equals 1. So a comma b means 0 comma 1. Where is this point? This point will be somewhere on the y-axis. That is imaginary axis. Here, this point is 0 comma 1, or you can say iota. If you join this point with the origin, then this radius vector will make 90 degree with respect to positive axis. This means the value of theta, that is argument of the complex number iota, that is argument of iota, is 90 degree. And this distance is 1. So modulus of z is equal to r is equal to 1. So if you put here r is equal to 1 and theta is equal to 90 degree, that is pi by 2. So z, that means iota, can be written as 1 into e to the power I pi by 2. That is e to the power I pi by 2. So you can say iota is equal to this. This is Euler form of iota. So what you do, you just start from here. So z is equal to iota to the power iota to the power iota. And from here, iota to the power this iota. This iota, this middle iota, we can say this middle iota equal to e to the power I pi by 2, and power of this is iota. That will be equal to iota e to the power, and these both. Here one thing, this power and this will be multiplied. Suppose e to the power b to the power c, then what? You will get e to the power bc. So e to the power, if you multiply this both, pi by 2 iota square. So I to the power e, and iota square is what? Minus 1. So minus pi by 2. Now again you write this iota in polar form. Polar form. So what you will get? Z is equal to e to the power iota pi by 2. This is for what? This iota. And power of this is e to the power minus pi by 2. So z will be equal to e to the power pi by 2. Again, this power and this power will be multiplied. So pi by 2 e to the power minus pi by 2 into iota. Into iota. So if you compare this with z is equal to r into e to the power I theta, what will you get? Here nothing means 1. So value of r is 1. You have iota here, iota. So value of theta is this. This is theta. That means r is equal to 1 and theta is equal to pi by 2 e to the power minus pi by 2. So the complex number z, the complex number z is equal to I to the power iota as modulus of 1, and argument is this thing, pi by 2 e to the power minus pi by 2. This is the argument of this complex number and modulus is 1. A student generally can make a small mistake here. The question was given at z is equal to I to the power iota. And I read this expression, this last expression. Well, I started from here at the upper part of. If you start from lower part here, z is equal to iota to the power iota. If we start from here, that means if you write this iota first as e to the power iota pi by 2, and then this iota, you will get wrong answer, because you are doing like this, 2 to the power, suppose 2 to the power 3. So this is equal to 2 to the power 3, that is 8. This is okay. But if you start from here, 2 to the power 3, that means 4 to the power 3, you will get wrong answer. So don't start from lower part, start from upper. So our answer is this thing, okay?